Hey everyone, welcome to yet another episode of my video series on Effective Java by Joshua Bloch. It's sort of a textbook to code video series where I take topics and principles from this book, and I'm hoping to do it with many other books, and expound on these topics and try to understand them and try and see what value or what we could derive from what are in these books. And today, of course, we're on item 3. So I've already done this on 2 other items. And it seems to be going well. I certainly can improve on certain points. Maybe above all, on brevity and trying to convey the points succinctly. But saying that though, I want to start off with the proviso. So if you did watch the other 2 episodes, you could skip this bit. I'll leave a timestamp as to where exactly you could skip to, just to save your time. So for starters, this is not a tutorial. That's a very, very important caveat. I'm not a teacher. In no way am I a Java expert. In fact, the more I'm learning about Java, the more I'm realizing how much of an expert I'm not. I'd like to think of it as the blind leading the blind. In this case, though, I'm really not leading, but let's say at least formally, because this is a YouTube video, kind of formally, I am leading the blind somewhere. But that also means that because I'm blind, I can make mistakes and run into a wall or something. This is only a exploratory disquisition. That's pretty much it. Trying to make sense of things. The best, I would say, analogy, day-to-day analogy I could use is what would happen in a university tutorial where we have a bunch of students, we have an assignment or a problem statement or some concept you're trying to grok. Of course, there's a tutor, but in this case, there really isn't a tutor, but just a bunch of students getting together, trying to make sense of some programming concept. And needless to state, this is a programming video, so it makes sense to have all the code that I use on GitHub, where you could go and play around too. So I shall leave a link down below in the description, not only to my code, but even to the code that Joshua Bloch has published himself on his personal repository. So without further ado, let's get started on item number 3, which states enforce the Singleton property with a private constructor or an Enum type. And this is still, of course, a part of chapter 2, which is regarding creating and destroying objects. So Singleton was one of the design patterns that was originally, I don't know if the word is originally, but let's say popularized by the Gang of Four in their great software engineering book, Design Patterns. And a Singleton is a design pattern that ensures that a class can only have one object, or as Joshua Bloch states in the book, a singleton is simply a class that is instantiated exactly once. Singletons typically represent either a stateless object, such as a function, or a system component that is intrinsically unique. So this creational design pattern, which I said again was proposed or popularized is a more accurate term by the Gang of Four, it's something one would hear about a lot if you're an OOP programmer, which is most of us. And it's got many advantages, which is probably why we've been told by the great, wise, sagacious programming gurus to implement it. So I found a few advantages of it. Keep in mind though, if you do follow this link, this is on Refactoring Guru. By the way, if you do want to understand different design patterns, this website, Refactoring Guru, is fantastic. It'll visualize things and use analogies to the real world, which personally for me, I always find that helps me comprehend things much better. So this design pattern, the Singleton pattern, they've expanded on that topic here. They've listed out not only advantages, but also some cons, as you can see here, some disadvantages too. I'm not going to touch on those because, going deeply into the Singleton pattern is probably a bit out of scope for this video. But some of the advantages are you can be sure that a class has only a single instance. That really helps with maintaining a certain, let's say, state of an object, more from a business perspective, let's say. So we instantiate a class and we give an object a certain state. And then generally a client would expect this object to behave a certain way. And forcing or implementing the Singleton pattern ensures that this object doesn't behave in ways that the client won't expect. So it helps to sort of maintain the encapsulation of a class. And yes, you gain a global access point to that instance because obviously only one object exists in memory. Whoever that's going to use that object will still use that one single object. The singleton object is initialized only when it's requested for the first time. So that's kind of like I guess the lazy loading pattern. That again is good because we don't want to create unnecessary objects. Generally, that's bad. That's a bad, almost like an anti-pattern in OOP. And on that note, Joshua Bloch continues. There are two common ways, to implement singletons. Both are based on keeping the constructor private and exporting a public static member to provide access to the sole instance. So the first approach is using a public static final field where the member field that holds this instance is final. Let's explore that and try and make sense of it. What we have here is a public class called Elvis. By the way, most of this code I've taken from Joshua Bloch's. The code is used in the book itself. I've just sort of refactored it to make it a bit more easier for us to understand. For me to understand, I should speak individually because I don't want to pretend as if I'm speaking on behalf of other people here. For me to understand, and as you can see here, the instance is declared final, so that object becomes immutable. So the Elvis class really has only got a simple method called leave the building, which states, "Whoa, baby, I'm out of here." I guess I'm a bit too young or from a different generation to really get the Elvis Presley jokes, which Joshua Bloch has made in this book. He's kind of a bit, before my time, let's say. In any case, the constructor, of course, is private because this gives the class instance control, as I've stated in the comment here. And then it's simple as this. When we do get that instance, access that instance, and you can probably see here, we aren't creating any object using the new keyword or whatnot. We're simply accessing this static member, which belongs to the class itself. And then through the static member, which gives us that object, the instance, we are accessing this method. So if I do run this, it'll just say, "Whoa, baby, I'm out of here," which is really what this object does. There we go, right there. And on this bit of code, Joshua Bloch states the private constructor is called only once to initialize the public static field Elvis instance. So that happens here. The class itself is instantiating itself with this private constructor because obviously it has access to this constructor within itself, and that object is stored in the instance variable. So yeah, the private constructor is called only once to initialize the public static field Elvis.instance. That's this. The lack of a public or protected constructor guarantees a mono-Elvistic universe. So the idea is, as I did show here, the client code, you can't instantiate this class. It's impossible because the constructor is private. Exactly one Elvis instance will exist once the Elvis class is initialized. No more, no less. Nothing that a client does can change this, with one caveat. This is an interesting point, and I shall comment on that in a bit. A privileged client can invoke the private constructor reflectively with the aid of the accessible object .setAccessible method. If you need to defend against this attack, modify the constructor to make it throw an exception if it's asked to create a second instance. So, firstly, I would say, before I say anything or comment on what Java reflection is, watch this video by Code with John. Obviously, links down below in the description. I've read blog posts, whatnot, on this idea of Java reflection, but so far, no one has explained it simply and plainly the way John does in his YouTube channel. Just in general, Code with John is a fantastic YouTube channel. I really appreciate his pedagogy and kind of what's the word I'm looking for? How pedestrian, and I mean that in the positive sense, he makes Java seem to people like me who are still trying to, truly understand the language. So Java reflection, let me try and explain what it is. As the name suggests, it's a way for a object or a class to introspect or reflect on itself. So what it does is generally, of course, a client can't go around tampering private methods and setting setters or getters in a class. That's not allowed. That violates the OOP principle of encapsulation. However, Java does allow this concept called reflection, which from what I've read, it's mostly for frameworks. So mostly for Java framework builders, that it does allow a class like this, which has a private constructor and which don't have any setters, which don't have any getters, to still implement that from outside the class using Java reflection. In fact, let me quickly pull out a more of a formal definition of what Java reflection is, because I think it's important to know the concept at least. So yes, as I said, this is a definition from Oracle docs, like not really the Oracle docs, sorry, it's more of a technical article. Written in 1998. That was a year after I was born. Reflection is a feature in the Java programming language. It allows an executing Java program to examine or introspect upon itself and manipulate internal properties of the program. For example, it's possible for a Java class to obtain the names of all its members and display them. That's an important point here. That introspection can be done runtime, so when the program is being executed. But better if you just watch this video. It's 22 minutes, well worth your time. So the second way Joshua Bloch has delineated on creating or implementing singletons is using a static factory method. Now, if you don't know what that is and don't know the benefits of using a static factory method, I would link you to the first video in the series, which is item 1, that talks about the pros or the virtues of using the static factory method. And item 1 states, consider static factory methods instead of constructors. But for all intents and purposes within our topic, really it does the same thing. So if you take this example, which again is another class called Elvis, why isn't it opening up? There we go. So yes, same concept. The constructor is still private and we only have one object being created here within the class. And instead of the client directly accessing the member variable, that member variable is private in this case, and we rather get it through the static factory method. Oh, this bit here, the read resolve, we'll get to that soon. For now, just ignore line number 15. And clearly, as he states here, you can see it in the code itself. One advantage of the static factory approach is that it gives you the flexibility to change your mind about whether the class is a singleton without changing its API. So what he means by that is, if you look at the public field approach, since we're directly accessing that singleton via the public member variable, it doesn't really give us a flexibility if we do want to not have a singleton, let's say, if we don't want to fill a singleton pattern. And I should probably add this here. He also states in the previous paragraph, I should have read that before, the main advantage of the public field approach is that the API makes it clear that the class is singleton. The public static field is final, so it'll always contain the same object reference, which what he means there is from a client perspective. I've used an inline variable here, by the way. It says here Elvis, and we're getting that single instance. Now, it's a similar thing we're doing here. The only difference with the static factory method is we're accessing it through this method getInstance. Now, because it's a method, we can play around with it and do what we want, so to speak. Which is why Joshua Bloch states it gives you the flexibility to change your mind about whether the class is a singleton without changing its API. We don't really change anything in this method. What matters is how we handle this object or what we do inside it from a client's perspective. An example Joshua Bloch has used is something to do with multi-threading. In a multi-threaded environment, the factory method returns a sole instance, but it could be modified to return, say, a separate instance for each thread that invokes it. That makes sense. We don't want there to be problems with multi-threading by having a single object that all the threads share. That could probably corrupt the state of that object. I don't know, just to, thinking out loud here. Now we sort of come to a bit of an ancillary point, but I think is nevertheless important. A second advantage is that you can write a generic singleton factory if your application requires it. So what is a generic singleton factory? Let's try and make sense of it. Firstly, as per usual, I will leave two links to two different, one Stack Overflow answer and then a blog post regarding this concept of type erasure, which is what allows generic programming in Java, and how it happens and why it's necessary for generic programming. But it's not really within the scope of what we're discussing here. It's still important to understand though. So what's a generic singleton factory? First of all, I should say we'll be covering this in item 30 of this book, so probably next year. Therefore, we shall go into more detail in that video. And item 30 simply states favor generic method, but apropos to generic singleton factory, in that item, Joshua Bloch states, because generics are implemented by Erasure, so that's what I meant by this type erasure bit. Please go read up on that blog post article on that blog post, as it'll really expound on the matter. Because generics are implemented by Erasure, you can use a single object for all required type parameterizations, but you need to write a static factory method to repeatedly dole out the object for each requested type parameterization. This is a very cool concept once you see it in action, which I shall show. It's a bit of a tongue twister, which I shall show in a bit, because it is pretty cool how it all comes together. So the kind of definition that I came up with for what a generic singleton factory is, it allows to create multiple singletons. That is not a oxymoron. You will see why that is in a bit, that behave the same way. So it's kind of got like a same super type, which mandates how it behaves. Using generics allows to use a single object for type parameterization. So I'm kind of repeating what Joshua Bloch stated, and casting is not required. That too you shall see. So I've got the example here. This too I took from item 30, but I just realized that before I do go through the example and explore the code, I did mention those two, the Stack Overflow answer and then this blog post, but I didn't really even expand on what it is or what they are. So I want to read out a bit of like introduction in this article regarding type erasure, because type erasure is what allows, firstly, the generic singleton pattern, but also using generic programming in Java generally. Generic programming in Java generally. Gosh, that's funny. So what does this person say? By the way, this article was written by Bishal Kumar Dubey. So what does Bishal state here? Generics concept is introduced in Java language to provide tighter type checks at compile time and to support generic programming, as I said. The way to implement generics, the Java compiler applies type erasure to replace all type parameters in generic types with their bounds or object if the type parameters are unbounded. The produced bytecode, we shall go into the bytecode bit too, therefore contains only ordinary classes, interfaces, and methods. Insert typecasts if necessary to preserve type safety. That is also something we shall explore. Generate bridge methods to preserve polymorphism in extended generic types. So you will see the third point here, that polymorphism bit in this example that I'm going to show soon. So the Stack Overflow answer kind of explains it this way. So we have this class, of course, here, which is simply a list. Sorry, did I say class? I mean, we have the list interface and we have the array list class. And it's the generic type, where the type parameter we are passing is a string, and then we're just adding it and we're getting it. But in the bytecode level, it really compiles like this. It does do the casting for us. Now, this is not required for us to do because we're using generics, and the type erasure allows this. Going to the example, here's how the generic singleton pattern works. This instance, we have a variable called identity function, or identity fn. We have a variable identity function, and keep in mind, object in Java is a superclass for all other classes. Therefore, any subtype of this type can be passed into this. So we have this private static final member variable called unary operator, and then we have a static factory method. What happens here is that method, we can pass a type parameters, similar to how you would pass a parameter to a method, but in this case, it's a type. So then, in the client side, you'll firstly see that I'm not using any casts here, and I have two lists I've defined. Two arrays, not lists in this case. A string array right there. I should probably zoom in a bit more. I apologize. The string array, and then we have a numbers array. So into the same class, I'm passing I'm creating an instance of that class, same string, and I'm getting that object, same string, same number, and I'm passing, in this case, the type string, and in this case, the type number. Now here's where it gets interesting. Despite the different types, it's still using the same object. We're still, as Joshua Bloch states here, doling out the same object into different types. So in this case, we can apply this and then print out all the strings. And in this case, print out all the numbers. But when we run this code, you'll see here, why can't I, okay, forget about it. When we run this code, you'll see here, the object is still the same object that it's using for both these cases, despite them having different types. So I'm printing out the object here, same string, same number. It's still this object, the identity function object, that's passing, or this single instance. So it's beautiful. That's what allows generic programming, because these are of different types, yet that object is being passed to these different types to be used and abused, let's say. So that essentially is what generic singleton factory is. It is a factory. We've got a factory here because it's producing or we're creating an object, but no class is being used. I think that's the biggest advantage I've seen from that pattern. And afterwards, Joshua Bloch states, a final advantage of using a static factory is that a method reference can be used as a supplier. For example, Elvis getInstance, which is the method reference, is a supplier and Elvis is the type you pass into it, which is the example I've used here. So let's try and understand, what does it mean? What does he mean by method reference being passed as a supplier? Firstly, from the Oracle docs, it states, what's a supplier? I want to understand. It's a functional interface supplier. Sorry, the functional interface supplier contains one method, which is get, that takes no argument and returns an object. But what's important to understand is this get method represents a function which does not take any arguments but produces a value of type t. So yes, the get method doesn't produce any arguments, but it has a type. The type could be passed as a generic. By the way, that latter bit I read from this article, again in Geeks for Geeks, which I'll leave a link down below in the description, which explains what a supplier interface is, written by this person, Sil123. So this is a bit hard to get intuitively, even though most of us in functional programming use a method reference, but the method reference requires a supplier. This functional interface, supplier interface, requires a supplier, and we need to pass it a type. In this case, with the class Elvis, we could pass the type Elvis as the generic parameter, as of it being of type Elvis. I don't know how else to explain it really. It just seems like it's something that allows us to do functional programming, and which is why Java has introduced that interface. Probably it was in Java 8, I think. And yes, the static factory method allows us to do that essentially because of the getInstance method that we define right there. In any case, I hope that explanation did do some justice to what a supplier interface is. If not, please go read the Oracle docs. Honestly, I didn't really find it too interesting, so I didn't go too deeply into it. But it just seems like something Java introduced to allow functional programming. But back to this. This bit is on still providing this singleton guarantee when serializing classes. To maintain the singleton guarantee, declare all instance fields transient. So what does transient mean? That means it won't be serialized. And provide a read resolve method. This is the bit I said I'll get to a bit later, that bit right there. This ensures that there's the singleton property or the singleton pattern is followed during serialization. However, it's not really worth going too deeply into it. Sorry, you know what? Before I I'm going everywhere with this, I'll finish the rest of that sentence or that paragraph. So I'll say, to maintain the singleton guarantee, declare all instance fields transient and provide a read resolve method, which he points to in item 89. I shall get to that too. Otherwise, each time a serialized instance is deserialized, a new instance will be created, leading, in the case of our example, to spurious Elvis sightings. So firstly, that idea of read resolve method, there's a whole chapter in the book on serialization. Serialization. Why do I find it hard to pronounce that word? Serialization. Where in item 89, which is why I said it's not worth spending too much time on this, because Joshua Bloch in fact says don't use read resolve methods. In item 89, he states, for instance control, so that's what we're doing here. We're practicing instance control. Prefer enum types to read resolve. So we're going to get to enum types next. Therefore, it's not really worth going too deeply into what this read resolve method does. But just in general, because it always returns this single instance we defined here, it enforces singleton once again, but this time especially during serialization. Can't pronounce that word. And according to this definition by Michael Myers, I've left a link to that. It's a blog post in the description too. Read resolve is used for replacing the object read from the stream. Why can't I read today? The only use I've ever seen for this is enforcing singleton. Oh, sorry. This was from, in fact, a Stack Overflow answer, not a blog post. But nevertheless, I shall leave a link to all of that down below in the description. When an object is read, replace it with the singleton instance. So when this object is read, it's going to replace it with this instance. This ensures that nobody can create another instance by serializing and deserializing the singleton. However, it makes no sense to go too deeply into read resolve because technically or theoretically, as per the sagacious advice of Joshua Bloch, we shouldn't even be using this method. We should be using the third technique or the third way to enforce singleton property, which is with a enum type. Not a enum type, using a single enum. I don't know why I said enum type. Makes no sense. This is by far the simplest way. It's, I think, 2 lines of code, if I'm not mistaken. So let me open it up. It is, in fact, yes, really, I don't even know if you consider this is more like a member variable, but it's 1 line of code. This is the simplest way to enforce singleton. Look at that. Just 2 lines of code, really. 1, 2, I don't know. I don't want to start a debate here. What's wrong with me? And really, all we're doing is storing that instance, and ipso facto that it's enum, we get most of these things we were trying to explicitly declare in the source code by virtue of it being an enum. So yeah, it provides serialization for free, and by default won't be able to instantiate multiple times because they're static and final effectively. In Java, every enum is implicitly a subclass of the enum class, so it cannot be used if singleton needs to extend a superclass. Oh yes, this is an important point. He gets to this in the end of the paragraph. The only disadvantage of using an enum I wouldn't even say disadvantage, more of something to be wary of when using an enum is this last bit, which I shall touch on a bit in a bit. My constant struggle to talk. The best approach, this approach may feel a bit unnatural. This is what Joshua Bloch states. So yeah, I mean, I don't know if in my few years of programming, I haven't really used an enum for much other than as being a container for holding constants. So it does feel a bit unnatural. But a single element enum type is often the best way to implement a singleton. And then he states, this is the bit I said I'll touch on, note that you can't use this approach if your singleton must extend a superclass other than enum. Though you can declare an enum to implement interfaces. Of course, because in Java, we can't extend multiple classes because by default, any enum is already extending the enum superclass. Let's say Elvis had to extend a class called human. That wouldn't be allowed because if we use enum. However, we could probably get through that through interfaces. So not really a big deal. That was a much shorter video. It was a much shorter item too. And that's it. That's item number 3. That's so essentially the idea is unless we have to extended superclass, the Singleton, then just use enums to enforce Singleton property. And we also did discuss initially some of the advantages of using a Singleton. On that note, I shall thank you for letting me again go about these things like a drunken sailor and get lost sometimes in my own musings. It is really interesting though. It is quite interesting how, as I said many times already, how all these items are interrelated, kind of like the Bible. The next item, item number 4, which I'm hoping to cover soon, which again is a shorter item, it's probably the shortest item in this book, is enforce non-instantiability with a private constructor. We've sort of already done that. We've already sort of covered, de facto covered that item in this item, because all the examples we used did have private constructors, but it's worth, when I say there's an example, right, this one right here. But of course, as Joshua Bloch has identified, it's worth going into detail as to why we need to enforce non-instantiability. Saying that, once again, thanks for watching. I'll see you in the next one. Cheers.